Hey guys, all right, this is 10-5 notes, so you can do the homework after this. We're going to talk about hyperbolas. Hyperbolas, just really quickly, are this part of the conic sections. Hyperbolas can do one of two things. They can open to the left and to the right. It's like two parabolas, really. Or it can open up and open down. Okay, those are the two case scenarios with hyperbolas. This is an absolutely crazy definition. Just ignore it. We'll talk about this later. But again, remember ellipses, how ellipses have the two foci in between the two ellipses? Well, think about hyperbolas. It's almost like an inside-out ellipse. So think of an ellipse as two parabolas opening toward each other, and it's opening toward the two focus points. Hyperbolas are like inside out, two opening the other way, and the foci are on the outside. All right, let's look at equations of ellipses. There's plus signs in between for equations of ellipses. Notice this, guys, they both equal 1, right? This right here, to remind you of an ellipse, when the a squared is first, is an ellipse that opens up like this, that turns like kind of sideways. When the b squared is first, it's an ellipse that's like up like that. All right, a hyperbola. Watch the difference, okay? The a squared is always first in a hyperbola. The things that switch up are the x's, the x squareds, and the y squareds. So when you have an x squared first in a hyperbola equation, notice there's a minus sign and a minus sign. When the x squared is first, you are talking about a hyperbola that is opening to the left and to the right, okay? This is a vertex, this is a vertex, and you have this axis called a transverse axis that kind of is horizontal in this case. And you would have these two focus points that are on that transverse axis that would be outside of the hyperbola. This would be the center. Okay, now if you're talking instead that the y squared is first, now you've got a hyperbola that opens upwards and downwards. Check it out. Now your vertices are on the hyperbola, but now it's a transverse axis that is vertical that goes through those two vertices. And now your foci, which are still going to be on that transverse axis, are kind of above the hyperbola and below the hyperbola. That is it in a nutshell. This stuff right here is all the stuff I just said. Here again, the x squared is first. It opens left and right. Transverse axis is horizontal. Then we have, I'm going to talk about the asymptotes in a second. Next case scenario is now the y squared is first. The hyperbola opens upward and downward. And now you have a vertical transverse axis, okay? Let's talk about the easiest way to graph a hyperbola. Well, again, we want this to equal 1. So I'm going to divide this whole thing by 225 to get it equaling 1. When I divide this by 225 and this by 225, now watch what happens when I reduce the fraction. 9 goes into 225 25 times. So I'm going to now have it going to be x squared over 25 minus, here I'm going to say, well, 25 goes into 225 9 times. So it's going to be y squared over 9 equals 1. Check it out. My x squared is first. So now I know, because my x squared is first, it's going to open this way and this way. This is always a squared, and the second one is always the b squared. So watch. My a squared is, if my a squared is 25, that means my a is equal to 5, okay? Now, I should tell you this. A is always going to equal the distance between the vertex and the center of the hyperbola. The center in this case is the origin, okay? So A, my distance and my vertex is going to be 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4, 5 to the left. How do you know I go left and right? Well, because it's under the X. And also, I know it's going to open left and right, okay? The B is the distance, is what you're going to do, is you're going to go now, because it's under the Y, I'm going to go up. The b in this case is 3, right? Because b squared is 9. I'm going to go up 3 and down 3, okay? Now the easiest way to describe how to graph a hyperbola is to take those dots that I just put in and draw a rectangle. Now you're going to want to draw a diagonal right through the center of the hyperbola, through the origin, and through the corners of that rectangle. See that? And again, like I said, the x squared is first, which means I'm opening left and right. I'm going to draw like a hyperbola that kind of butts up against those diagonal lines. Those diagonal lines we're going to call asymptotes because they kind of butt up to the hyperbola. Okay, that is the easiest way to graph a hyperbola. Okay, so what I'm going to do now is I'm going to have you stop the video and I want you to try to draw this one. The only clue I'm going to give you is that the y squared is first. So now it's going to open upward and downward. I'm going to let you guys figure out how to do that one. Okay. Now we have to talk about C. We have to talk about where are the foci. Well, the foci are always going to be on the transverse axis. They're always outside of the hyperbola. I want you to remember that in an ellipse, we had a formula for figuring out C. In an ellipse, that formula was c squared is equal to a squared minus b squared. Well, guess what? In a hyperbola, and we're putting stars next to this, c squared is equal to a squared plus b squared, okay? All right, so for instance, we want to find the foci of this, okay? Here's what you do. Well, the x squared is first again, so I know it's opening left and right, okay? I know that this is a squared. If this is a squared, then I know that a is the square root of 36, which is 6. I know this is b squared, which means that the square root of that must be 2 for b. If I wanted to graph this thing, well, I know it's opening left and right, so I'm going to start at the center, and I'm going to go to the right 1, 2, 3, 4, 5, 6. I'm going to go to the left 1, 2, 3, 4, 5, 6. And you know what? I'm not graphing this thing. I'm just going to do a quick rough graph knowing it's going to look something like this, okay? So if I wanted to figure out the foci, well, guess what? C is going to be just like it is in an ellipse. C is the distance between the focus and the center. Okay, I'm now going to use my formula. C squared is equal to a squared plus b squared. Okay, so c squared is equal to 36 plus 4. So c squared is equal to 40, which means that c is equal to the square root of 40. Okay, I'm going to put that in simplest radical form and make it the square root of 4 square root of 10, which is equal to 2 rad 10. Okay, now what is 2 rad 10 really in terms of a decimal? Well, think about it. The square root of 36 is 6. The square root of 49 is 7. 40 is somewhere in between 40 and 49. It's a little bit closer to 36. I'm just going to guess it's about 6.4. I don't know for sure because I don't have a calculator on me, but I'm pretty sure it's about that. So it's 6.4 about. So think about it. Foci would be, here's 6. 6.4 is maybe right around there. So this is one focus point, and that point right there is the point 2 rad 10, comma 0. That's one focus point. The other focus point, I'm now going to go that to the left. So that right there is my other focus point. And that point is negative 2 rad 10, comma 0. Got it? Good. All right. Rather than have you guys try this one, I want to do it because I want to talk about this. I want to talk about the fact that the y is first. All right, the y squared. That means it's going to open upward and downward, right? So think about this. If I'm going to have it open upward, downward, this is still my a squared, 25. So what's a? So I want to figure out what my foci are. So c squared is equal to a squared plus b squared, right? I know that this is going to graph like this. A is 5, so here's my center. I'm going to go up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. The reason why is because it's under the y squared. This is going to here's my quick sketch. It's going to open up and down, okay? Just a quick sketch. I'd want you to do something more accurate if I asked you to graph it. But anyway, c squared, that's what I'm interested in right now, is going to equal a squared, which is 25, plus b squared, which is 16. All right, so that's going to equal 41. So c is equal to the square root of 41. Again, that's probably about 6.4 something. So here's one focus point. Here's the other one focus point. Why am I doing this again? Well, because I want you to realize that now the point is going to be 0, comma, square root of 41, and 0, comma, negative square root of 41. Because now check it out, my transverse axis is vertical. All right, anyway, Let's see. What else do we want to talk about? Write an equation of this hyperbola. Oh, this is a good one. Okay. Well, first of all, I know it's opening left and right. So that means the x squared is first. This is the form it's going to be. What do I not know? Well, I know A. Look at A. Check it out. There's A. It's the vertex. The vertex is there. A is always the distance between the 0 and the vertex, the origin and the vertex. So what's A in this case? It's 4. So look, this is what I know so far. It's x squared over 4 squared, which is 16, minus y squared over, I don't know what B is. I don't know. I don't have a rectangle where it's showing me what the B is. So how do I figure that out? Well, I use my handy dandy formula of c squared is equal to a squared plus b squared. Right. All right. So c squared is equal to, I know it's 16, right? Oh, wait, hold on. I know what c squared is, don't I? Let's check it out. What is c? C is the distance between the focus and the center. Here's c. It's 5. So I'm going to make this a 25 is equal to 16 plus b squared. Now I'm going to solve for b squared. I'm going to subtract 16. B squared is equal to 9. Check it out. Put that 9 there. There's your equation. Okay. Write an equation for the hyperbola with the vertices there and foci that. And that's kind of the same thing. You know what? You guys try that and we'll talk about it in class. All right. We'll see you guys later. Bye.